when their is equal.
No, but if cardinality is equal, you cannot say that two sets are equal, correct? Because there are some infinite set, they are also equal. We can see that. But the cardinality of those set is not same. Because we cannot talk about cardinality there because they are infinite.
When one set is the subset of other and other is also subset of
Very nice, very
first
good,
one.
Payal. This is what I was expected. When do I call two sets are equal? A is equal to B when one is subset of other and other is subset of that one. That is A is subset of B and B is subset of A, then we call it as A is equal to B. Correct? So by using that, you can prove this. You can prove this. Bxr is equal to x plus r times b01. Now look at the left hand side. This is a set. Look at the right hand side. That is also a set. Graphically, can you visualize this thing? What is this B01? What is this B01? Tell me. You can say this is B01, correct? What do you mean by B01? It is a circle with center 0 and radius 1, correct? This is unit circle. Now, if I multiply R into B01, what I am going to have actually? Yes, if I multiply R into this set, what I'll be having? Write B01. What is this B01? It will contain set of all x such that distance from x to 0, it is less than 1. Do you agree? This is the definition of B01. I am going to take all those x which are lying with you. So if I multiply r, that means what? If I multiply this set by r, what do you mean by that? Those element they will go somewhere else, correct? Suppose यहाँ पे कुछ लोग हैं. If I multiply 5 with everyone, so these element will go somewhere else. Everybody will go somewhere else. Do you agree? Do you see that? But that sorry, that won't go anywhere. Actually, this set will be quite longer. This will happen. If I multiply r, that means this set will be quite expansion. If your r is less than 1, then it will contract. Otherwise, it will expand. Okay? And if you add x plus this, then the center will change. Center 0, 0, it will change to another center. That is the center x. In this case, I should not write x or something else because I have written dx0. I hope this is clear to you. Take some time. Do you understand graphically what I am writing? Do you understand right hand side first of all? Do you understand this part? That means if I multiply B01 with R, my circle, the radius will increase actually. And if I do x plus, then it is same as shift of origin. I'm shifting it somewhere else. Yes.
Yes, sir.
If you're there may be two things. There are two possibilities you have. If your r is greater than 1, correct, then this will expand. If r is less than 1, then it will contract, something like this. If r is greater than, then this will become larger, and if r is less than 1, then it will become smaller. Something the same cycle. Is that okay? Now, if you add x with this, that means what? It will get translated. It will get, the center will change in that case. Here the center is same. Center is origin, but if you put x, then it will get changed. That is quite easy to see. Is that okay? Do you understand this? This is called contraction. This is called dilation. This is called dilation. This thing is called contraction. It is getting contracted, and in that case, it is dilation. It is getting expanded. Is it okay?
Yes, sir.
Good. Now, one more. I think we have proved this. Maybe I should write, or शायद मैंने homework दिया था क्या? नहीं. Let x comma norm. That is a simple exercise. Be an NLS non-linear space, and let small x belongs to x, and we are having 0 is less than r is less than s. We'll show that. I think we have done this. V of x comma r is contained in V of x comma s. Can you show this? I think I have talked exercise with this. Think about it. Can you show this? At least can you do it for R2? If I take x equal to R2, can you do this for R2? Graphically think about it. What you are having, you are having two radius and a circle, and having same center, the radius is increasing. So what do you observe? One will be bigger and other will be inside that, correct? So that means Vxr is subset of Vxs. And since R and S are strictly less than, so they won't be equal in this case. Do you agree? Yes. Do you see some issue? What happened in the discrete matrix space? If I take an example of discrete matrix space, in that case, if the radius are different, then also I can have the same open wall. Bxr may be equal to Bxs. So what is the difference between discrete matrix space and this NLS, non-linear space? Yes. In a non-linear space, this is true. But if you take the example of a discrete matrix space, this is not. Because I can have equality. I have shown you so many examples. I hope you know that. Do you agree with me?
Yes, sir.
Let me just show you. I have shown some examples. Yeah, do you see that? Vx1, Vxr, they are not subset. They are not proper subset. They are equal actually. Center is same. So what was the problem what is the extra condition? Here you are given it is NLS, non-linear space. And in that case, you are given only the matrix is discrete matrix space. Correct? So whenever the you should always focus on the domain in which you are working. And R2 is a non-linear space. So it is quite clear in R2. Similarly, for the closed interval, see open interval x comma लिया, close लिया तभी भी चलेगा ये. You take the boundaries also, then also it is okay. Same thing is okay. Now let us see some. Let us see open ball in C01. How does open ball see? Uh, we have started by the definition of open ball. We have seen in the different domain how the open ball looks like. See, I have, yeah, there are the three. This is an open ball, standard open ball, but this is also open ball. In which norm? Norm 1. This is an open ball. And what about this? In the norm infinity, this is also an open ball for me. Correct? So, similar to this, I have defined on 301 the three norms. Norm 0, norm 1, norm infinity, and norm 2. These two norms, we have defined it for functions also. Na? So, the next question you should ask, sir, how does the open ball look in that space? You understand? Let me summarize it quickly. I have asked you that we can define these three norms in terms of yeah. Yeah. Do you see that? I have defined again these three norms. Norm infinity in terms of function. Norm 1 in terms of function. Norm 2 in terms of function. Correct? Now the next question you should ask, sir, can I have open ball in this space? And the answer is yes, you can have the open ball. Can you visualize it? Can you see the graph? That is the. So let us see. Let us see open ball in norm infinity norm 1. Okay. Let x equal to say interval 0 1 and v is equal to C01. Do you understand what is C01? Ritika, do you understand what is C01? It is non-linear space of C01 means what? It is continuous function, continuous real valued function on the interval 0 1. On the interval 0 1. So this is the space I'm having under the sup norm. So let us visualize how B0 epsilon. So this is what I would like to visualize, B0 epsilon, correct? Tell me. The next question, how will you visualize BF epsilon? What is the definition? Write the definition. Write the definition. Let's see. What is the definition of B0 epsilon? Neha? What is the definition of B0 epsilon? What is the definition of BF epsilon? Why you guys are taking so much of time? What is the definition?
It is the set of all x such that d of
Let
x comma
me just B0 epsilon equal to set of all. Will it be x or it will be function? It will be set of function here, because here my space is what, C01. So B01 it will contain all the, say, phi I or functions phi, such that, what is the condition? Yes,
d of phi comma 0 is less than equal to x.
g of phi comma 0 is less than equal to, sorry, less than epsilon. But what is d of, we are taking sup norm, so it is just subtraction phi minus 0. So it is supremum of mod phi. Correct? That is less than 0. That is less than epsilon. What do you mean by that? Supremum of mod phi. So see, mod phi का value क्या हो सकता है? Either it can be positive or it can be negative, you know. So let us forget about this. Let us take this as any number, say y or mod y. So what is the graphically? Let me just draw it graphically. So this is y equal to epsilon, y equal to minus epsilon, and any function lying in this interval, any function, you draw any function. So any function lying in this interval, they belongs to the interval B01. In short, you can say an element say phi belongs to C01, lies in B0 epsilon. What is the condition it should have? If and only if its graph lies in the region bounded by y equal to plus epsilon and y equal to minus epsilon. How did I get y equal to epsilon and y equal to minus epsilon?
Mod of phi is less than epsilon, so minus epsilon is less than phi is less than epsilon.
And what is the limit for x? कहाँ से कहाँ तक हो सकता है? And x is from 0 and x is equal to 1. So this is a, maybe you can consider this is a rectangle part. से 0 to 1 तक ही लेते हैं हम लोग. Let us. Oh. So those functions whose graph completely lie between these two, between this rectangle, they are called the element of the open ball. Is that okay? Here I am looking at the functions, huh? That is, you need to make sure. Say phi1, f, g, phi2, something like this. So those functions which are completely lying in this graph, they are called as elements of the open ball. Read this statement. An element phi belongs to lies in the B01 if and only if its graph lie in the region bounded by y equal to plus epsilon, y equal to minus epsilon, x equal to 0, x equal to 1. Is that okay? Now, by similar way, can you say something about what about BF epsilon? Can you draw the graph? What can you see here? Write the definition first. What is the definition? What does this will contain? Set of all, you can write set of all G belongs to C01 such that what is the condition it should satisfy? Yes, D of F comma G. That means what? Supremum of minus G. That is less than F. Is that clear? Isn't it? Now what do you mean by supremum of F minus G? What is the condition on G I am having? The G should lie between. In the previous case, what was the condition for this phi? Either again, by writing the definition. What was the condition on this phi? Phi lies between minus epsilon and plus epsilon, correct? We got the condition that phi should lie between minus epsilon and plus epsilon. So that's why we draw minus epsilon का graph और epsilon का graph draw किया and we got a bound, correct? But here, what do you think the bound would be?
F plus epsilon, F minus epsilon.
Very high. Very good. This is your F epsilon and this is your F minus epsilon. Is that clear to everyone? That means what? Again, the line will be as it is 0 to 1. ये bound तो ऐसे ही है, correct? So all those functions which lie inside this is called the element B F epsilon. Is that okay? Right, H, G, phi or something. Okay, so let me just write it. Phi lies in B F epsilon if and only if its graph lies in the region bounded by the curve what are the curves? Y equal to F plus epsilon, y equal to F minus epsilon, and x equal to 0 and x equal to 1. Is that clear? So these are the four curves I'm bounding. ये हो गया x equal to 0 का curve. This is x equal to 1. This is y equal to F plus epsilon, y equal to F minus epsilon. So this is open ball in C01. Do you all agree? See, again, the word is open ball, but it does not seem as ball in this space, in this C01. So it all depends on your space and the norm, how you define. तो ये हो गया. लेट अस सी इंफिनिटी वाला कैसे दिखेगा, नॉर्म इंफिनिटी. और नॉर्म एफ, नॉर्म इंफिनिटी, लेटेस्ट सी पहले नॉर्म एफ देखते हैं. कंसीडर एनएलएस x is equal to C01 norm 1. See, I'm working on the function. Space मेरा C01 है, so it is all continuous function from the interval 0, 1 to R. Okay. Where what is norm f defined? Can somebody tell me what is this defined as? Yes. How does this norm f1 define? Yes, anybody? Hello. What is norm f1? Norm 1 है ये.
Mod of f1 integration 0 to 1 mod of.
Yes, integration 0 to 1 mod of f of t dt. Isn't it? Correct? How can you visualize this B01? Can you see the B01? Yes. What is this thing actually? What is your right hand side? Can you see that? It is. What is this right hand side? Integration 0 to 1. We have done Riemann integration. Don't take that much time. What is this B01? Oh, sorry, norm F1. What does that mean? That is area under the curve mod f of t. Do you agree? So what is the right hand side actually? Right hand side is area under the curve. But if I'm talking about B01, so B01 कैसे लिखेंगे हम लोग? Yes, it will contain all those functions. Say you can say G belongs to C01 such that norm of G minus 0, since one so norm of G you can write norm of G1, it should be less than 1. Do you agree? That means what? What do you mean by norm G1 is less than 1? That means area under the curve. What is the curve? Mod G. That area should be less than 1. Then I will call that. So B01 में क्या रहेगा? You can say that an element belongs to this B01 if F belongs to B01 if and only if the area under the graph of mod F is less than 1. Correct? Is that okay? Do you agree? Let us see some example. So, what is the graph you need to see? What is the main focus? Suppose I am having a graph which goes from here to here and then here to here, and say it comes here and then here. And say this point is y equal to 1 by 4 and this is minus 1 by 4. So what can you say about this graph? And say 0, say this is 1 by 2 and say this is 1. So what do you need to see first? What do you need to see? If you like to check whether f belongs to B0 or not, the question is whether f is in B01 question mark. Can you tell me whether it is B in B01 or not? You can say this is 1 by 4 and this will be what? 3 by 4. What you are supposed to do here? Yes. The first thing you are supposed to do is find the area of mod f. पहले तो ये function दिया है f. So you have to calculate what is mod f. Mod f means what? Negative part है that will also go top side. Do you agree? Is that clear to you or not? This part, this will go on the top. If you take mod f, so what is the my mod f actually? This is the mod f. The whole thing will be the mod f. What you have to do? You have to find area under this curve. Can you do that? You have to find this area and this area and add them. Whether it is less than 1. If it is less than 1, the answer is this f lie in B01. So can you quickly tell me what is the area? That is quite simple here. You both are triangle only into height. You can do that 0 to 1 by 2. 1 by 2 into 1 by 4, 1 by 8, 1 by 8. So you are having 2 by 8. That is 1 by 4. Correct. So your area is 1 by 4, which is you can say that f belongs to B0. Do you agree here? You agree or not? Come on, fast.
Yes, sir. Agree.
Good. Now let me just give you another function. Check whether this lie or not. Tell me what about this function? Whether this graph lie in B0 or not, you can call this graph as G. What do you think? What you are supposed to do first?
Whether it whether it lies in
No,
whether
no,
it
no.
is continuous and it is in the 0 to 1.
No, that seems okay, no? It is continuous, it is integrable, but whether it lie between B01 and B01, the norm I am defining like this norm 1. Norm 1 is integration. That means what? What you are supposed to
Area
see?
under curve.
Exactly. Area under the which curve? Not G. You have to see mod G. But here mod G is same as G. Do you see that? Because everybody is in the first quadrant only. So I don't care about that mod G and G are same here. So I just have to see this area. And what is this area?
Two.
2, correct? And इधर मैंने half से I think I have not multiplied, so it will become 1/8. Half into base into height होता है ना triangle. So here the area is 2. It is not less than 1. So you are going to say that G does not belongs to B0. Is that okay?
Yes, sir.
Yeah, nice. Good. One of the most important property which we have discussed in your FYBSc class, that is called Hausdorff property. Any of you, do you remember what is Hausdorff property? Yes. What is
Any
Hausdorff
two
property?
any two real number have distinct neighborhood.
Very nice. Any two real number have distinct neighborhood. In the case of R, it was quite simple. Very good. It's good you remember that. If you have a 2 point, they are distinct, correct? I can have two distinct neighborhood for them, isn't it? That is all okay if it is much closer to this guy. Then also I can have open ball for both of them, which are disjoint, isn't it? So this is what your Hausdorff property. So now we have defined open ball, so we should write a Hausdorff property here also. Given two distinct point, x and y belongs to x, there exists r greater than 0 such that bxr intersection byr is empty. Do you see both the statement are same? जो हम लोग ने FY में पढ़ा था इधर, whether they are same or not? What do you think? Yes. And what is the changes here? Here I am having this guy as x, this guy as y. I just need to make sure something. Just tell me what is that. There exists R such that this is. And what do you think the distance between these two? Distance between x y क्या रहेगा? Can you say something about distance between x y?
Is greater than R.
Yeah, it is greater than, even it is greater than 2r also, correct? Do you agree, Payal? Because यहाँ
Yes,
से
sir.
यहाँ तक ही r हो गया, यहाँ से यहाँ तक ही r हो गया, so distance of x y that is greater than 2r, isn't it? So I just need to find this r. Think about it properly. Can you find this r? What are the different things can happen here? You just have to decide this r. Shall we start the proof? So how are you going to start? You are given two distinct point and you are supposed to prove this is. So the best way to prove is prove by the method of contradiction, correct? What is the method of contradiction? Given any two distinct point x and y, such that bxr intersection byr is empty. So what should I start? Suppose it is non-empty, isn't it? This is the way to prove. Do you agree?
Yes, sir.
So let x comma y are two distinct points in x to prove bxr intersection byr that is empty. We prove by method of contradiction. Suppose not. That means let z belongs to this bxr intersection byr. Yes. What next? What can I write? That means what? Implies z belongs to both the interval. It follows from the definition of z belongs to bxr and z belongs to byr. Is that clear, everyone? What do you mean by z belongs to bxr? That means distance between x and z that is less than r. And what about this? Distance between, can I say, z and y that is less than r. Agreed?
Yes, sir.
What next? How do you find some contradiction?
Distance between x and y is less than or equal to distance between xz plus distance between zy.
Very
Triangle.
nice. Very good. So we are going to consider distance between x, y. So that I can write it, this is less than equal to distance between xz, distance between zy. But I know something about this too. I know this guy is less than r. This guy is all less than r. So I am having distance between x and y that is less than 2r, which is a contradiction. Do you agree? In the graph only I told you something. Do you see what is distance
Yes, sir.
between x and y? It is always greater than 2r. From here, that is quite obvious. So this is a contradiction. This is a contradiction. So what should I say? Hence, that z should not belong. That is bxr intersection byr. It should be empty set. Agreed. Is the proof clear? The proof was very easy. You just need to understand this graph. That's it. Yes. Shall we go ahead? Is the proof clear? Just go through the proof. क्या क्या किया फटाफट check करो. Then we'll go ahead. Yes. Now let us see so many different example of open set here. Uh, shall I go ahead? Is that clear?
Yes, sir.
Yes, sir.
Good. Now can you tell me what are the or just let me write find all open sets in a discrete matrix space. We have done something in this matrix space. Now I need you to find all the open set discrete matrix. So first of all, actually मैंने open define नहीं किया ना. We have just defined open ball. So let me define what is open set for you. Before defining open set, first definition is let A be a non-empty subset of a matrix space X comma D. Okay. Let us define induced matrix. Let us define B A comma R. This is a new notation for us. That is B E R, where the suffix E denotes open ball in the matrix space A comma D. In the matrix space A comma D, centered at A and radius R. R should be positive. Okay. So why I am writing suffix A? Do you understand this? First of all, this is same as जैसे करना वैसा ही कुछ है. I am having a space X, correct? In this space, I am having one more set A. This is a set A, correct? And in this set, I am having my open ball. So this thing is called VAR. This is say E, and if you take the radius, it is R. So this guy is called VAR. Just like we have defined induced distance, correct? So just like BAR क्या रहेगा? It is, you can call it as induced open ball. Is that clear? Do you understand what is this BAR? What is this notation? We are talking about the open ball which is contained in E. And where is this A? It is contained in whole set X. That means all this A, जो भी मैं A लूंगा, that will be in the set A, capital A. Is this clear? Yes. There is a question. Show that B A X comma R that is equal to B X comma R intersection A. Can you show this? Just check whether can you prove this or not. You are supposed to say two sets are equal. BAX comma R. What do you mean by that? Just now I shown you. And what is this BXR intersection A? Do you understand? First, do you agree कि ये same रहेगा BAX comma R? This should be first of all. Do you agree with this or not? If yes, you should able to prove this. And what do you mean by BXR? Huh? This is open ball in the matrix X comma D in general. X comma D में कहीं पे भी open ball रहा. That is called BXR. Is that okay? Can you prove this? Maybe I'll just give you homework. Try to prove this. This is a very easy exercise. Graphically, it is quite clear. You just have to write two sets are equal. One is already subset of other. Just you have to prove the other way. Yes. So let us now define what is open set. A subset U which is in X of a matrix space is said to be D open if for each X belongs to U, there exists R greater than 0 such that BXR is contained in U. You agree? ये same ये उधर भी हम लोगों ने पढ़ा था. The changes is here I am referring this as D open. You can refer it as open set भी बोल सकते हो directly, but it is better to say D open because all the time we are focusing on the metric. कौन से metric पे काम कर रहे हैं हम लोग वो उससे भी difference होता है. So here we are not working on just on R, R2, R3. We are working on any metric space. So it is better to call it as a D open. And the definition is same. For each X belongs to that set, there should exist a R such that that open ball should be contained in U. Do you agree with the definition? If you are not confused with the metric, then you can just say open. There is no issue. Maybe I'll just write it. If there is no source of confusion. So is the definition clear first of all? Got the definition? What do you understand by the definition? Let us see. Suppose you are having a set X. Suppose this is the set X जो तुम्हारा मैट्रिक्स स्पेस है one more set, say U. So this is U for me. Okay. Now I am going to call this U as D open if and only if open set if for all x in U there exists R positive such that BXR is contained in U. Do you understand the definition? What do you mean by that? That means take any x here. I should always able to find a R such that the open ball that should be completely live. I should able to find the open ball. Do you agree? Take any point in the set U, I should always able to find an open ball which is completely contained inside. That is important, huh? This open ball should be already inside the set U. That means all the element of this open ball should be of the set U only. It should not be of any other guy. Is that clear? Yes or not?
Yes, sir.
Yes. So this is the definition of this is why this is how we call U is called as open set. This is the definition of open set. Good. Now the first question. Find all open sets in discrete matrix. So what are the different open sets are there in discrete matrices? So what do you know about discrete matrix is first of all? What are the different open sets are there in discrete matrices? That means what are the different U I can have such that open ball should be contained in that U. So before doing this, you should know what are the open balls in the U. Sorry, what are the open balls in discrete matrix space? So what is the definition of say B x comma R? What is the definition? Set of y in x such that distance between x and y that is the definition, right? So what do you know about this? It depends completely on your R. Do you agree? In the case of discrete matrix space, it depends completely on your R. Agreed or not? What if your R is less than equal to 1? Then what is BXR? Yes. Tell me. We have done this. Yeah, I'm waiting for the answer. Payal,
Yes, sir.
what is this? space. What is discrete matrix space?
Sir, it is a matrix space where uh, the distance is when the 2 points are equal, the answer is 0, and the distance between any 2 points is 1.
Correct. What can you say if r is less than equal to 1? What can you say about this? What happens if r is less than 1? Yes. See why we are taking so much of time, I don't understand. You just take some arca value, r equal to 1 by 2, 1 by 3, 1 by 4. You take any arca value. Suppose if I'm taking r equal to 1 by 3 here, so what I'm saying, distance between 2 points is less than 1 by 3. But in discrete matrix space, there are only two choices. Either the distance will be 0 or it, and they are saying it is less than 1 by 3. So less than 1 by 3 it should be. That means this y should be same as x. That is center only. This is just a singleton set. If you take r equal to 1 also, then also it is just a singleton set. And what about if r is greater than 1? If you take r equal
Null
to 2
set.
or 3, then it is whole set. Do you agree? Isn't it?
Yes, sir.
Let me just call it U. So it is the set U. Agreed or not? So what can you say? So you see that any singleton set is also open set here. And the whole set is open, that is clear. So you saw that any singleton set is an open ball for you. Do you agree? Agreed or not?
Yes,
What
sir.
do you see? This is a singleton set, but this is left hand side is an open ball. So any singleton set is an open ball. So what can you say? What are the open set in discrete matrix space? What happens if I take 2 points? What happens if I take 2 points in a say set B? It contains x and y, where x and y both are in that set U. What can you say? What is the question? Whether this set is open or not? What can you say? How do you check a set is open? If take any point, you should find a open ball that should completely contain inside this, correct? So
Yes.
there are only points, but if you take points, they are already an open set only. They are already an open balls, correct, na? Because I know that singleton sets are open ball for me. For each set, they are the only open ball. I don't need any radius. There exists a R, you can consider like this. There exists a R such that this singleton set is an open ball. Can I say same thing for if I have 3 element, 4 element, 5 element, because each element singleton set is the only set. Singleton set is the open ball for me. So it is a conclusion I can say. Hence, what can I say? अरे बोलो भाई. Every set in discrete matrix space.
is open set.
Exactly. Is that clear? The question was find all the open set in discrete matrix space. The answer is every open set is every set in the discrete matrix space is open set. And later on we will be proving that every set in discrete matrix space is closed set also. That means in discrete matrix space set both open and that is called clopen. This set are called clopen set. This is closed set also, open set also. So in later class, we will prove that it is closed set also. This is called clopen. Closed also, open also. The name is given clopen set. Is that clear? Do you understand? The next exercise, prove that an open interval in or open ball, you can call it as. Let me just write like this. Let x comma d be matrix space x comma d be matrix space. Let small x to x and r is greater than 0. Is open. Prove this. We have done this proof. If you remember in your SYBSc, we have proved any open ball is an open set. What are you supposed to do? What are you supposed to do? You have to choose any open ball is an open. That means take any element in this open ball. I have to find a R such that there should exist an open ball which is completely contained inside that. So graphically, if you see, तो तुम लोग को समझेगा. Here my set is open set. You have to prove that take any point I should be able to find an open ball. So what radius should I choose? The main important thing is the radius. Huh? So what radius I should choose? Such that the open ball which I am making, that open ball will completely lie inside that. You just think about it. Yes? Is the question clear? Yeah. What is your answer? Empty set open in the metric space X comma D. What do you think? What is the answer? Whether the empty set is open or not?
Yes, sir.
How can you prove that? You're saying yes, then you should able to prove. There are so many examples of open. Maybe I'll be discussing in the next. Keeping the forum open for you guys to think. Try to write the definition of open sets. Go through the notes. अभी तक जो भी किया है, just go through and then try to see. Next question would be, what is the answer? Of course, think about it. Is that okay? So these are the questions. There are so many question marks in today's class. I am giving you one day, that is tomorrow. We'll meet day after tomorrow and we'll discuss these questions. Okay. Is that clear?
Yes, sir.
Yeah. Good. Okay, we stop now. Thank you so much, everyone.
Thank you, sir.
Yeah, I'll just put the attendance form in the chat. Just 1 second.